Hi, my name is Eman. Today I'm going to present a research titled Multi-User Privacy and Security Conflicts in the Cloud. Cloud systems make it easier and more convenient for multiple users to work together and co-create, co-own, co-edit, and co-manage files and folders in the cloud. It's estimated that over 2 billion users now use the cloud system to store and share hundreds of billions of data items, and by 2025 there will be more than 100 zettabytes of data stored in the cloud. So, due to the collaborative nature of the cloud, it can lead to privacy and security conflicts between the users involved. For example, when a user adds someone to a shared folder, while conflicts involving multiple users, MCs in other domains such as social media, smart homes, and others have been studied before, conflicts specific to the cloud have not been explored. Therefore, my colleagues and I conducted an empirical study of experienced MCs in the cloud. In this study, we first aim to identify conflicts involving multiple users that can occur when collaborating in the cloud and to analyze their causes, characteristics, and impact. Then, we aim to investigate how users respond to such conflicts and what strategies they use to manage them. We finally develop guidelines and best practices for designing systems that can detect, prevent, and resolve conflicts among multiple users in the cloud. In terms of our method, we conducted a mixed method survey including 1,050 participants. We designed 4 surveys to examine both the initiator of the action that caused the conflict and the affected users, those affected by the action, on both shared files and folders. Following the critical incident technique, CIT, to explore the MCs that occur when multiple users collaborating using files and folders in the cloud. Then we use thematic analysis to analyze qualitative data and descriptive and inferential statistics to analyze quantitative data. Moving on to the results. Here I will go through some of our results. The results can be found in the paper. Our analysis revealed that almost all participants experienced MCs. 99% reported a multi-user conflict, and only 1% of the participants reported that they had never experienced an MC. We found that MCs happened in the cloud because of the initiator's actions when sharing, permission setting, editing, deleting, and when restructuring and renaming files and folders. This table shows an example of MC for each action. For example, when sharing, an MC happened when one member of the shared folder adding someone new to the folder. For editing, an MC happened when a member makes undesirable edits. Why did the initiators perform the action? The most common reasons from the initiators on why they performed the action that led to the MC are mistakes, lack of technical skill, denying access purposefully, cloud security and privacy concerns, misjudgment, storage management. In denying access purposefully, initiators said they removed access from the affected because affected didn't need access anymore, misconducted or ended their relationship, or because of interpersonal disagreement. In the misjudgment, initiators explained that they misjudged the situation that led to a conflict. For example, they underestimated the sensitivity of files. Why and how did the MC affect affected users? There were 5 main reasons why affected participants were affected and that led to the MC. The reasons were loss of confidentiality, loss of availability, lack of consent, loss of integrity, members not following the agreed rules. For example, in loss of confidentiality, affected participants reported that they were left unhappy because files and folders containing personal, private, or confidential data to them, and they complained that they lost the privacy and security of these data. Resolution strategies. Our analysis indicated that users develop and use various strategies to resolve MCs. Some MCs are resolved through non-technical strategies, for example, via conversations with the initiator and affected, discussing the issue and or apologizing, explaining if needed. This indicates that some MCs result from acts or mistakes that can be quickly resolved by just talking about the issue. Some MCs require technical interventions. The initiator may have to redo or reverse their actions, adjust permissions, or provide protection for the concerned file or folder. This figure provides all strategies used to resolve each MCs. The details of resolution strategies are in the paper. Next, I will zoom into the figure to show two specific examples. The first example, participants use conversion, a non-technical strategy to resolve MCs related to sharing. For example, to resolve a conflict that happened when adding a new member, participants use conversing to negotiate and set a new sharing policy between the group members. The second example, participants use redoing, a technical strategy to resolve MCs related to editing and deleting. For example, participants recreating the file to handle MCs related to editing. This figure shows an overview of the relationship between our main findings, the initiator's action that can lead to MCs and their reasons, why the affected were not happy, and why they chose to communicate or not communicate, the strategies used to resolve the MCs, and reasons why some MCs were not resolved. Lastly, it shows the impact of MCs. Here we are comparing cloud MCs with social media MCs because it's the domain where MCs has been studied the most. Difference is, cloud MCs are not just about sharing. They can happen due to other actions like editing, and they happen more around work-related issues which has different impacts such as reduced productivity. Similarities. Resolving MCs, cloud users employ offline, corrective, and preventive strategies similar to those developed in social media. An example of corrective strategies, our participant would delete or adjust the permission to suit collaborators' desires, which is similar to what social media users employ to control the visibility of unwanted content, such as untagging or sharing content within closed circles. Another similarity was lack of consent. In cloud, some MCs were due to a lack of consent from the initiator. Also in social media, users explained they were not happy because initiators didn't consult them. Design implications. We need to develop preventative and recovery support for cloud MCs. According to our findings, some MCs are resolved by reverting changes. However, some consequences, such as loss of privacy, cannot be reversed easily. Our recommendation is that mechanisms should support users in targeting reversible actions and non reversible results. Also, we need to develop mechanism for detecting the sensitivity of content, as some reported MCs were associated with the sensitivity of the content. Initiators revealed that they didn't think the content was sensitive before they shared the content. So, classifying data according to the sensitivity would help users make informed decisions about sharing data. We also need to develop new consent collection techniques to avoid MCs. Building these techniques could be impracticable in the cloud as taking consent for each cloud action may be complex, so it would be essential to study the applicability of using such techniques in the cloud. Lastly, improving support in collaborative interfaces. Future research could focus on building a new mechanism to decentralize administration right, taking power from one user but involving everyone in the decision making. We give more details of the discussion in our paper. Thank you.